Hi, I'm Dan Cortopassi. Welcome to Model Building. In this episode, I'm continuing my work on a freelanced Nn3 260 narrow gauge steam locomotive. In the last episode, I extensively modified the metal body casting of an N-scale Rivarossi 040 to make a boiler for my Nn3 narrow gauge locomotive. I fit the boiler and got it securely attached to the Marklin Z scale 260 mechanism that I'm using for this build. My goals for this episode are to prepare the 3D printed cab, remove the cast-on stack and steam dome, and prepare a new headlight. On Shapeways, I found something being sold as Nn3 conversion parts. The 3D printed set includes a cab, a tender body, a pilot, and some details including a smokestack and domes. My next goal is to prepare the cab and make any adjustments necessary to make it fit. Right now the motor is touching the back of the boiler. I'll need to shorten the boiler a little to leave room for the front of the cab. There's a cast-on pipe just forward of the original cut line. After carefully examining the parts, I've determined that I can shorten the boiler to here to make room for the cab. Since the original cut with the razor saw took so much time, this time I'm using a motor tool with a fiber-reinforced cutting wheel. It would have been better to make the cut here in the first place if I'd known at that time how the parts would fit together. After some cutting and grinding, the boiler is now shorter. I'll clean up the end with a flat file. I'll test fit the boiler against the cab to make sure I have a good fit and that the cab is square. This looks pretty good. Now there's enough of a gap to fit the front of the cab. The cab itself comes with a floor. I'll need to remove most of that to fit it over the Marklin motor. I haven't worked much with 3D printed parts before, so I'm proceeding carefully. I'll start by drilling holes around the edges of the floor. Now I'll use my sprue cutters to cut the leftover material between the holes. Well, that almost worked. The material is a little more brittle than I realized, and I cracked the cab side. Fortunately, I bought a spare when I started this project. I tried the same thing on the second one, only I spaced the holes much more closely together. This time I was able to get the floor out. I'll clean up the cut with some careful filing. Now the floor is completely gone. Test fitting the cab instantly reveals that I have more work to do. The leftover strip across the back needs to be removed to clear the motor. Something is hanging it up in front as well. Holding the cab gently but firmly against my plate glass cutting surface, I can trim the back with an X-Acto knife. The notch in the cab front needs to be enlarged to fit over the motor mount screw. I'll mark where I need to cut with a pencil. I'll use my motor tool to grind out the opening. After a little trial and error, the position of the cab relative to the boiler is looking pretty good. The walkways on the sides of the boiler flare out a little toward the cab. The width is good in front but too wide in back. I'll need to cut these down so that they're more even. I'll start with my motor tool. Then I'll clean up the cuts with a flat file followed by some sandpaper. Now the width of the walkways is a much better match for the cab. I'm not going to glue the cab on just yet. I'll leave it off for now since I want to do more work on the boiler casting. The stack on my model is slightly damaged on the top. Since I want to replace it in the headlight with aftermarket castings anyway, I'll go ahead and remove them. Again, I'll start with the motor tool, followed by files and then sandpaper. I'll use 320 followed by 400 grit for a smooth surface. I'll need to drill a hole for the new stack. It should be centered on top of the boiler and above the steam cylinders. I'll be using Detail Associates Part 8002 for the new stack. The white metal casting doesn't need much cleanup, just a light sanding to get rid of a faint mold seam. The stem on the stack fits into the hole in the boiler. I'll hold off gluing it for the moment. It bothers me to see the mounting screws sticking up so far over the sand dome. I'm going to get rid of the bump on top of the dome using a flat file. I took off just enough to get rid of the bump. I don't want to flatten the top of the dome completely. Now the screw takes up the space where the bump was. I was considering trying to recess the screw into the dome, but I think I'll leave it like this. It gives the top of the dome a little more visual interest. I'll finish up by polishing the top of the dome with some 400 grit sandpaper to remove any scratches left over from filing. I'm not crazy about the steam dome on the model. It looks like a camel hump to me. I'm going to replace it with Detail Associates Part 8004. This is a fluted dome that looks more like something you'd see on a narrow gauge locomotive. The casting has some nice detail on top and a mounting pin on the bottom. First, I'll cut off most of the dome with my motor tool. I stopped a little short of the sand dome since I don't want to mess that up. The rest will come off easily with some pliers. Now I can use the edge of the cutting wheel to grind down the excess material around the base of the dome. I have to work very carefully here. I don't want to destroy the detail molded into the boiler, and I don't want to make any gouges that would need to be filled. Next, I'll carefully work the area with some small files and sandpaper until all traces of the old dome are gone. Using a finger as a guide for the file is useful for preserving details like the boiler banding. Now that it looks like I've removed all traces of the old dome, I'll brush a little gray paint on the area. You could use any color for this step. Once it's dry, the paint will help to show any imperfections that are hard to see in the bare metal. This looks good. I can see a few brush strokes, but the dome is gone and I haven't sanded any dents or depressions into the boiler. Now I can give the area a final sanding with some 400 grit paper. Next, I need to drill a mounting hole for the steam dome. I'll start with a small drill bit and a pin vise. I'm working slowly and carefully here. It's hard to get the drill to start a hole where you want it on a curved surface like this. Once the hole is started, I'll put the drill bit into my motor tool to speed things up. The original hole is a little too small for the steam dome, so I'll ream it out with a number 54 drill bit. The steam dome stem has some flash on it. I'll cut it shorter to get rid of that part. Now I can test fit the dome. Unfortunately, the dome isn't seating properly. There's a noticeable gap around the base. The dome has a concave base, but the curvature doesn't quite match the boiler. After a few tries, I've decided that I need to snip off the mounting pin and sand the concave base of the dome. My first thought was to wrap a piece of sandpaper around the boiler and run the dome along it. That helped, but it's still not seating quite right. A round object slightly smaller than the boiler, like this X-Acto knife handle, works better. Now the dome is fitting much better. I'm going to use a drop of CA to tack glue it in place. Once it's dry, I'll drill up through the bottom using my number 54 bit and a pin vise. I found a piece of steel wire in my stash of modeling materials that is the same size as the hole. I'll use my motor tool to cut a short length of it. Now I can use some CA to glue the wire into the hole to reinforce the dome. For the headlights, I'm going to use Detail Associates Part 8009, which has two white metal castings. I want to use one on the locomotive and put the other on the tender. Both are identical, so I'm just going to show my work on the front one. In order to make the castings lightable, I'll first need to drill them out. Each headlight casting has a mounting stem. I'm going to use that to clamp the casting in my hobby vise. Next, I'll use a 1/16 drill bit and a pin vise to hollow out the inside of the light casting. The metal is soft and drills easily. I prefer a pin vise for this type of work instead of a motor tool. It's slower but much easier to control, and it really didn't take that long to hollow out the inside of the light. While I have the part in the vise, I'll use a small file to remove the mold seam along the top of the light casting. There are several ways to mount headlights on small steam locomotives. I kind of like the look of the headlights sticking out over the smoke box front, but it would be difficult to make this kind of mounting secure. I don't want to build something that's going to break every time I touch the engine. Since this is freelanced and I can do things how I want, I'm going to opt to put the headlight on top of the boiler in front of the smokestack. I'm going to cut the pin off the bottom of the headlight casting. Now I can file the underside flat. For the headlight that's going on the engine, I'll use a partially rounded file to make a concave trough under the headlight. This will help to fit it on the round boiler better. It looks like I can still make the front of the headlight stick out a little over the boiler face without compromising the mounting strength too much. Cool. To light up the headlights, I'll be using 402 size warm white surface mount LEDs. I got these on eBay with wires pre-soldered. They're super tiny. I'll use a smaller drill bit to put a hole in the bottom of the headlight casting. The exact size of the hole isn't critical, but it has to be big enough to fit the LED. I made this LED tester from a 9-volt battery mount, some wire and alligator clips, and a 750 ohm resistor soldered to one of the leads. With the LED inside the casting and hooked up to the tester, it looks like it'll be plenty bright. I found some 1/16 aluminum tubing in my stash of supplies. I'm going to use my miter box and razor saw to cut a short length of tubing. The tubing is short enough that it'll fit inside the hole I drilled in the headlight casting, with space in the back for the LED and in front for a fiber optic lens that I'll add later. Once I'm happy with the fit, I'll use a tiny drop of CA glue to secure the tubing. Now both the front and rear headlight castings are complete. I'm going to set the tender headlight casting aside for now. I'll put it back into the bag that it came in. I'll need to drill a hole on top of the smoke box that will line up with the hole in the bottom of the headlight casting so that I can run wires from the headlight back to the decoder. Using the front headlight casting as a reference, I'll mark the location of the hole on the boiler. I'll make a dimple with a small drill bit and a pin vise. It's slow going at first. I'm being careful so that the drill bit doesn't wander. Next, I'll use a number 58 bit and a motor tool to drill a hole at an angle toward the back of the engine. The drill size isn't critical, but the hole has to be big enough to fit the wires. I'll flip the boiler over and use a 1/16 drill bit and a cordless drill to make a hole for the wires on the inside. The wires from the headlight will enter through the angled hole at the top of the boiler, pass through the unused threaded hole that was where the original Rivarossi 040 mounting screw went, and then enter the boiler through the new hole that I just drilled. With everything back together, I can see that the front headlight is angled down a little. I want to fix that. I'll use my rounded file again to remove some more material from the rear of the headlight casting on the bottom. The metal is soft and I didn't have to remove that much material. Now it looks much better. The headlight is level and pointing down the track as it should. It takes a little more time, but small fit and finish issues like this make a world of difference in the finished model. At this point, the smokestack and headlight are not glued on. I'm going to leave them that way because it will make it easier to paint the model later. To improve the appearance of the smokestack, I'll deepen the indentation in the top with a 332 drill bit held in my fingers. Just a little drilling gives the stack more depth. A little flat black paint in here when the model is done will make it look like it goes down into the smoke box. It's always good to consider the paint scheme when building a model. I'm planning to finish the engine in overall black with a silver or graphite colored smoke box. Leaving the headlight and smokestack as separate parts for now will make it easier when it comes time to mask off the smoke box later. If I were planning to paint everything black, then I could go ahead and glue these parts now. Other details that will be painted black can be added to the boiler now. This is Detail Associates Part 8017, a set of 2 pile generators. I'll only need one for this locomotive. I'll save the second one for another engine. These parts are really tiny. To make it sit on the rounded boiler top better, I'll use my partially round file to gently shape the bottom. When I'm satisfied with the fit, I'll glue it behind the steam dome with a drop of CA. That's a good place to leave things for now. I think the project is coming along pretty well. My inexperience with 3D printed parts led me to wreck the first cab. Thankfully, I learned what not to do and the second one worked. Taking care of small fit and finish issues will make for a better model. Leveling the headlight was well worth the small amount of time it took to do it. Planning ahead for painting and masking is important. Depending on the paint scheme, sometimes leaving parts unattached will make painting much easier. For this project, I've been keeping a tally of how much I've been spending. The total from the last episode was $70. The Shapeways detail parts set that I bought was about $15. I'm only going to count one, not the one that I broke. The Detail Associates parts usually sell for more than the price marked on the package. When I've had to buy them, they've averaged around $5 each on eBay. I already had the dome in my parts bin from many years ago, so I won't count any cost for that. I used both headlights and set 8009, so that's $5. I only used one stack and one pile generator from each of those packages, so altogether that's another $5. That brings us to about $95 in parts so far for this build, including the Marklin mechanism. I'm pretty happy with the progress that I made so far. In the next episode, I'm going to continue to add detail to the locomotive. Thanks for watching.